This video is about factoring and solving a quadratic equation with a value other than 1 for the a. So yesterday, when we were factoring polynomials, we always had a value of a of 1. So every time we always had x squared. This time, we need to be able to get the a value to be 1 first in order to factor these problems. So we're going to use GCF, and then we're going to factor using a box problem. So in number 1, it's 5x squared plus 15x plus 10. So in order to get an x squared, I know that I have to factor out a 5. So my GCF is 5, so I can divide all of these numbers by 5. So I can get x squared plus 3x plus 2. Now, what's in parentheses now has a value of 1 for the a, so we can factor like we did yesterday, where we're going to see what multiplies to 2 and adds to 3. Well, the only numbers that multiply to 2 are 1 and 2. So we're going to rewrite the 5 that was already out front, and then on our parentheses, we're going to break it down to x plus 1 times x plus 2. In number 2, we have negative 2x squared minus 28x minus 98. So in order to get it to be an x squared, I can divide everything by negative 2. So my GCF is going to be negative 2, and when I divide that out, I get x squared plus 14x plus 49. So now I need two numbers that multiply to 49 and add to 14. So those numbers are 7 and 7. Those are the only numbers besides 1 and 49 that multiply to 49. So when I rewrite this, I have my GCF of 2 out front, and I have x plus 7 times x plus 7. Remember, if we have the same factor in parentheses, we can rewrite it as x plus 1 squared. Number 3, we have x cubed minus 7x squared plus 12x. Remember, we need x squared, not x cubed. So all three terms have an x, so we can factor that out as the GCF. So all of our exponents are going to decrease by 1, so we get x squared minus 7x plus 12. So now we need two numbers that multiply to 12 and add to negative 7. So we're looking for two negative numbers. So in this case, our two negative numbers are going to be negative 3 and negative 4, because those multiply to 12 and add to negative 7. So we're going to rewrite the GCF out front x, and then in the parentheses we have x minus 3 times x minus 4. In number 4, to get becoming an x squared, we're going to have to GCF out a number and a variable this time. So if I want x squared, I get rid of the 9. If I want all of these that have, I need to factor out the lowest exponent, which is x squared. So if 9x squared is my GCF, we're going to divide everything by 9 and decrease the exponents by 2. So we get x squared plus 14x plus 24. So now we need two numbers that multiply to 24 and add to 14. Well, two numbers that multiply to 24 could be 4 and 6, but 4 and 6 don't add to 14, so we need a different combination that multiplies to 24. So 2 and 2 multiplies to 24 while also adding to 14. So we're going to keep our GCF 9x squared, and then we're going to rewrite our parentheses. We have x plus 12 times x plus 2. Now we're going to factor and solve using the zero product property. So remember, we're always going to use the zero product property anytime that there is an equal sign. So right now, I can't factor this because it's not an x squared, but I know that they all have a 4 in common. So my GCF is going to be 4, and I'm going to divide everything by 4. So I get x squared plus 7x minus 44 equals 0. So before I can solve this, I need to factor using our box now. So what multiplies to negative 44 and adds to positive 7? So if I'm multiplying to a negative number, I need one of each sign. So 11 and 4, the only thing I need to figure out is which one is going to be negative. So if I'm adding to a positive number, my bigger number is going to be positive. So we have 11 and negative 4. So I get 4 times x plus 11 and x minus 4 equals 0. So now I need to solve using the zero product property. So in order to solve, I need to use anything that has an x gets set equal to 0. So I have these two quantities with an x, so I'm going to set each of them equal to 0. So x plus 11 equals 0, and x minus 4 equals 0. So in the first one, in order to solve, I subtract 11 from both sides. X equals negative 11. Add 4 to both sides. So x equals positive 4. Number 6, in order to solve this, I need to get it to be an x squared. So I know that 6x squared, I can take a 6 out of everything. So my GCF is going to be 6. So when I divide everything by 6, I get x squared minus 10x plus 21 equals 0. So now I'm going to have to factor. So what multiplies to 21 and adds to negative 10? So I need two negative numbers because they have to multiply to a positive but add to a negative. Two negative numbers that multiply to 21 are negative 7 and negative 3. Those both add to negative 10 together. So I get 6 times x minus 7 times x minus 3 equals 0. So again, I have two quantities that have an x in them. So I'm going to set each quantity equal to 0. So I'm going to use the x minus 7 and the x minus 3. So when I set those equal to 0, in order to solve in the first equation, I add 7 to both sides, and x equals 7. The second one, I add 3 to both sides, and x equals 3. Now, 7 and 8 are a little bit trickier because they're not set equal to 0. So in order to get them set equal to 0, I need to first move the 48 to the other side. So because it's a positive 48, I'm going to subtract 48 from both sides. And we get 3x squared plus 18x minus 48 equals 0. So in order to factor, I need to get x squared, which means I need to factor out a GCF. So instead of having 3x squared, I'm going to factor out the 3. So when everything divides by 3, I get x squared plus 6x minus 16 equals 0. So now I need two numbers that multiply to negative 16 and add to 6. So two numbers that multiply to negative 16, I need a negative and a positive. So I know two numbers that multiply to 16 are 4 and 4. But when I make one of those negative, that's going to add to 0. So that's not going to help. So a different thing that multiplies to negative 16 is 8 and 2. And I know 8 is going to be positive because I'm adding to 6. So when I factor, I get 3 times x plus 8 times x minus 2 equals 0. So in order to solve, anything that has an x quantity is going to be set equal to 0. So I'm going to set x plus 8 equal to 0. And x minus 2 equals 0. So in the first equation to solve for x, I'm going to subtract 8 from both sides. So x equals negative 8. And I'm going to add 2 to both sides. So x equals 2. In number 8, in order to get it set equal to 0, I need to add 39x squared to both sides. When I rewrite this, remember, you want to write it in order of your powers. So I have 3x cubed plus 39x squared minus 90x equals 0. So I need to get it to be an x squared, and right now it's a 3x cubed. So I can factor a 3 out of everything because they're all divisible by 3, and they all have an x with the lowest exponent of 1. So I can factor an x out of everything. So when I do that, I get x squared plus 13x minus 30 equals 0. So I need two numbers that multiply to negative 30 and add to 13. The numbers that we think of right away are 3 and 10. However, if I had negative 10 and 3, that's not going to add to 13. That's going to add to negative 7. And if I switch the signs, that's going to add to positive 7. So those factors of 30 don't work. So I need two different factors for 30. So two different factors are 15 and negative 2, and those add to positive 13. So I have 3x times x plus 15 times x minus 2 equals 0. So every quantity that has an x gets set equal to 0. So this one's special because it's a 3x. So this time I have three things that are going to be set equal to 0. 3x, x plus 15, and x minus 2. So in the first equation, we're going to divide by 3, so x is 0. The second equation, we're going to subtract 15, so we get negative 15. And then we're going to add 2 to get x equals 2. So this time, because all three things have an x, there's three solutions. Number 9 is an application problem. So find the dimensions of a rectangle with the area of x squared plus 9x plus 14. So remember that in a rectangle, we have two different side lengths. So when we are doing area is base times height. So to find the dimensions, we're going to factor this equation. So the equation is x squared plus 9x plus 14. So we need to know what multiplies to 14 and adds to 9. Well, the two most common numbers that multiply to 14 are 7 and 2. So we would have x plus 7 and x plus 2, which means the dimensions of the circle, of the rectangle, one side is x plus 7, and one side is going to be x plus 2.